Hello everyone, myself Kiran Kadakuntla, lecturer, Department of Electronics and Communication Engineering. Today we are going to discuss session 3 of unit 1, that is full wave rectifiers. Okay, so in the previous session, that is session 2, we have discussed about what is meant by rectifier, parameters of rectifiers like ripple factor, efficiency, peak inverse voltage, and other things. Then we have discussed about the expression for ripple factor and expression for efficiency. Later on, we have discussed about half wave rectifier. That is, we first understood what are the types of rectifier like half wave and full wave rectifier, and we have discussed about the what is half wave rectifier, what is its circuit diagram, how it operates, and what is the waveforms of half wave rectifier. Then we have seen some questions on half wave rectifier and the session 2. Today we are going to discuss about the session 3, that is full wave rectifiers. Let's go with the syllabus. So in this session, we are going to discuss mainly on these topics. First, we will be dealing with the definition of full wave rectifier. So here we will understand what is why it is named as full wave rectifier, what is the definition of full wave rectifier. Then we will understand the types of full wave rectifiers. Okay, because in full wave also once again we have a subtypes. Then we will understand the explanation of the types of full wave rectifier, that is working of center tap full wave rectifier, working of bridge type full wave rectifier. Okay, so these are the main topics we will be covering in today's session. Okay, let's begin with the full wave rectifier definition. So first we'll understand what is meant by full wave rectifier. Okay, in the previous session we have discussed about the half wave rectifier. Half wave rectifier is a one where it will be using only one diode and it will be conducting only for the half wave of the input signal. Okay, for remaining half it was having no signal. Okay, that's why it was called as a half wave rectifier. But today we are discussing the full wave rectifier. It means, as the name indicates, it is operating for the full wave of the input. So during the positive half cycle and during the negative half cycle, the output will be present. That is why it is called as a full wave rectifier. And it will be using the two diodes. Whereas of half wave was using only one diode, in full wave it is using two diode or four diode. Once again, depend upon its classification, we will be dealing in next. Okay, so it uses two or four PN junction diodes, and uh, the performance will be increasing compared to half wave because it is operating for both the half waves. So you can see the its efficiency will be 81.2 percentage, whereas if you remember the efficiency of the half wave rectifier, it was 40.6. So you can say almost it is double than that. Why it is doubled? Because it's working for the both the half wave, and even number of amount of ripples was more in the half wave. Here you can see it is 0.48. So the even ripple amount of ripple also reduced. Then the output frequency will be 2f naught, because for one cycle of the input signal it will be having the two positive half cycles. Okay, so we'll understand this with the explanation, and even in the next session we'll be dealing how we can get the efficiency value of 81.2 for full wave, and ripple factor is 0.48 for the full wave rectifier. Okay, so let's go with some statements of the related to the full wave rectifier. So first it says that a full wave rectifier is a circuit which converts an AC input voltage into pulsating DC voltage using both the half cycle of the applied AC voltage. So we know that the basically rectifier means which converts an AC input voltage into pulsating DC voltage. Okay, that is the statement of rectifier we already discussed. In this, it is using the both the half cycles, means positive half cycle and negative half cycle of the input signal. So it is using both the half cycle. Next one, unlike half wave rectifiers, which uses only half wave of the input AC cycle, full wave rectifier utilizes full wave. So as I already told, it is utilizing the both the half cycles. As it conducts for both half cycle of AC input, the efficiency is improved to 81.2 percentage. Ripple factor is reduced to greater extent to 0.48, and output frequency is 2f naught. 2f naught means double the input frequency. Okay, we will understand how it is double with the when we are dealing with the circuit diagram of a full wave rectifier. So this is regarding the definition of full wave rectifier. Okay, so here we are mainly here mainly we have to understand the difference between half wave rectifier and a full wave rectifier. Okay. Next, we will be dealing with the what are the types of full wave rectifier and how they work, and what is the difference between those type of rectifiers. Okay. So let's move to the next slide. So here we are dealing with the types of full wave rectifier. Okay. So in a rectifier, we have two types, that is half wave and full wave. Okay, we understood the difference between half wave and full wave. Now in a full wave, once again, we have a classification, that is center tap full wave rectifier. One more is a bridge type full wave rectifier. Okay. So these are the two types in a full wave rectifier. But since both are the full wave rectifier, the output will be present for both the half cycle of the input signal. Okay, so let's begin with one by one. So first we will deal with the center tap full wave rectifier. Okay, so now the thing is, it is named as center tapped full wave rectifier because it is using the center tapped transformer. Okay, so it is using center tapped transformer for its operation. So it is named as center tap full wave rectifier, and it is operating for both the half cycle of a AC input signal, and it is utilizing two PN junction diodes. Okay, remember in a half wave rectifier it was using only one diode. Okay, here it is using two diodes, and each diode will work for the one half of the cycle. Example, for positive half cycle, one diode will be conducting, for negative half cycle, the another diode will be conducting. So output will be present for both the half cycle, and each diode will be operating for the half of the input cycle. So it is utilizing two diodes for its operation. Okay, let's go with the statement. It is a single phase full wave rectifier that uses a center tap transformer, hence the name is given as a center tap. Okay, then it conducts output current for both the half cycle of AC input voltage, hence converts AC input voltage to DC output voltage for one complete cycle of AC input. Okay, it uses two semiconductor PN junction diodes for its operation. Okay, so remember, so how many diodes it is using? It is using two PN junction diodes for its operation, and it is using the center tapped transformer. Okay, here we will deal with the operation of center tapped full wave rectifier. We will understand its operation. Okay, so first the input will be taken from the AC mains. Okay, so AC mains will be supplying the AC input voltage, then it is given to the center tapped transformer. Okay, you can see here it is center tapped. Here we have a two diodes, D1 and D2, and this is the load resistance RL. Okay, so here in the transformer we'll be naming it as A, B, and C, so that when we dealing with the operation of its flow rectifier, then it's very easy for us to discuss the flow. Okay, so in this we can see the direction mentioned here. During the positive half it will be flowing like this, and during the negative half it will be flowing like this. Okay, this arrow mark indicates the flow of current, and here this diagram shows the waveforms of full wave rectifier. This is the input waveform. Okay, and this is the output waveform. Okay, this is the diagrams related to the center tap full wave rectifier. Let's understand its operation. Okay, so first we have an input. So this is our input, which is having the AC mains input, means normally it will be having the voltage of 230 volt, and what about the frequency? It will be 50 hertz. Then this is passed to the center tap transformer. Let's begin with the positive half. So during the positive half of the input cycle, okay, the point A will be positive with respect to point C. Means it is positive compared to point C, and there is no signal at point B. Okay, so when there is a point A is more than point C, then this positive is applied to the anode of the diode D1, and this side it is a negative. And since there is no signal from this part, so it is not turning on. So during this positive half cycle, D1 is forward biased and D2 is reverse biased, and D1 conducts and D2 become a non-conducting state. So during this positive half cycle, this is forward bias and it acts as a closed switch, and it starts conducting. Then that current start flowing in this direction. So this arrow mark shows the flow. So during the positive half cycle, only the current is flowing in this direction, D1 to the load. So output load is getting this positive half cycles from this diode D1. So in this half cycle, we are getting the output pulse from the diode D1, and D2 is in non-conducting state. Okay, this is regarding the positive half cycle. Let's After the positive half cycle, we have a negative half cycle. In this condition, point B, this point B is having the more value, or it's positive compared to point C. Okay, so when it is more positive than point C, the D2 will comes into forward bias, and D1 remains in the, and D1 will be in the reverse bias condition. Okay, so when it is forward bias, it acts as a closed switch and start conducting, and since it is non-conducting state, it acts like an open switch. There is no any current flowing through the D1, and only the current is flowing through the D2. So this in this direction the current will flow, and the current flow from B to diode D2, then it moves to the resistor RL. And you can see here in both the half cycle, the current is flowing in the same direction. So RL is experiencing the only one direction of wave. So during the negative half cycle, the D2 is conducting, then the current is flowing like this. The RL will experience the positive half cycle. So during negative half cycle also, the load is experiencing the positive half cycle. Okay. So this will continue during the next positive half cycle. Once again, point A will be positive compared to C, and D1 conducts, and load will be getting the positive half. Next again, for the negative half cycle, point B will be more positive compared to C, D2 will be conducting, and RL will be experiencing or getting the one more positive half signal. Okay, so this is the operation of a full wave rectifier, and you can see that it is having the output for complete cycle. Okay, for complete full wave, hence it is called as a full wave rectifier, and it is named as center tapped because it is using the center tapped transformer for its operation. Okay, so this is the output, and one more thing you need to understand, that is about the frequency. So you can check here, this is one cycle. Okay, so how many cycles it has? If you consider this is a one duration of 1 second and all, how many pulses it has, how many cycles it has? Only one cycle. For the same duration, check how many cycles we have. We have a two cycles, means the output frequency is double the input frequency. So whenever it is asked what is the output frequency of the full wave rectifier, it will be 2f0, means 2 times of the input frequency. Okay, so you must remember this. Whereas in half wave rectifier, it was only same as input, because for one cycle it was having only one pulse. So that was having the only same as the input frequency, but here we have a double the input frequency. Okay, so this is the operation of a center tapped full wave rectifier. I hope you understood the concept. Okay, so if you want to go with the circuit diagram, then we'll move on to the next topic. So if you understood this, let's move on to the next topic. Next topic will be bridge type full wave rectifier. Okay, so we understood the center tapped full wave rectifier, where we were using the center tapped transformer, and we were using the two PN junction diodes. Okay, let's understand this bridge type rectifier. So actually bridge type full wave rectifier will be using the 4 diodes. Okay, so in half wave it was using only one diode, then full wave center tapped full wave is using 2 diodes, and bridge is using the 4 PN junction diodes. Okay, and all 4 will be connected in the form of bridge. That is why it is named as a bridge type full wave rectifier, and it is using 4 diodes connected in the form of bridge, and it is operating for the full wave of the input signal. Hence it is named as a bridge type full wave rectifier, and it has a main advantage of eliminating the necessity of center tapped transformer, which was there in the center tapped full wave rectifier. In that kind of a rectifier, the center tap transformer is a must, which is expensive. Okay, so in this one we are eliminating that necessity. Okay, so let's go with its operation. It converts AC input to DC output for both the half cycles of AC input using 4 semiconductor diode connected in the form of bridge. Hence, it is named as bridge rectifier. Remember how many diodes it is using? 4 diodes. Okay. It may be asked in the examination how many diodes bridge rectifier will be using. You must remember it is 4. Next, as the center tap transformer is expensive and is difficult to implement, bridge rectifier is developed. Means it's like a advancement in the rectifiers. So like center tap transformer is expensive. To have as a solution, we are moving for the bridge type wave rectifier. Okay. So even for the bridge type also we have a good efficiency, that is a 80.6%, and it has a very less ripple factor. Okay. So it is also similar to your full wave or center tap full wave rectifier. Okay, so let's understand its operation. Okay, so here we have two diagrams. One is its circuit diagram, how it connected and all. Then this waveform is its waveforms. Okay, so you can observe here in this there is no center tap transformer used. It's normally step down transformer is used in this, and you can observe here we are using the 4 diodes and they are connected in the form of bridge. Okay, and we have one load. So now begin with the operation. So observe this, in which form the diodes are connected. So this is the format of diodes connected. Let's begin with its operation. So once again we will take the positive half cycle of a AC input signal and we will analyze the operation of this bridge. Then we will move on to the negative half cycle. Then we will analyze the circuit. Then we will understand how we get the output. So during the here also, for easy for explanation, we are taking the points S1 and S2. Okay, so this is S1 and this is S2, and here we have 4 diodes D1, D2, D3, D4, and these points is named as point A, point B, point C, and point D, and this is the output available with across the load. Okay, so during the positive half cycle, what happens? The point S1 is positive compared to S2, means the current is flowing in this direction. So when the current is flowing in this direction, can you understand or imagine which all diodes will be in a forward bias? So if you know the forward bias condition of a diode, even you can easily understand which all diode will come in forward bias in this state. Okay, so this is positive with respect to S2. So current flows like this. This positive is connected to cathode of this D4 diode. Okay, whenever the positive is connected to cathode, what will in which bias it will be? It will be reverse biased, because we know that the diode comes into forward bias only when the positive signal is connected to anode and negative signal is connected to cathode. But in this one, the positive is connected to cathode of the D4. That means it will be in a reverse bias. And this positive is connected to the anode of the D1. That means it is in forward bias. Similarly, this negative is connected to cathode of the D3. So it will be in a forward bias, and the negative is connected to the positive anode of the D2. So it will be reverse bias. So by this we can understand that D1 and D3 are in forward bias and D2 and D4 are in reverse bias. That means D1 and D3 is conducting and D2 and D4 are non-conducting state. Then the current is flowing in this direction because D1 is on. So current comes like this. It passes with the D1, okay, and it flows to the load, and similarly it is coming to the form. It's like S1 to A, from A to B because it's closed, then B to load, from there to point D, and point D to point C, and go back to S2. So this is the closed path during the positive half cycle. S1 to A to B, B to load RL, from RL to point D, D to C, and C to S2. This is the closed path during the positive half cycle, and in this the load RL experiencing the positive half cycle. Okay, so this is the operation of bridge rectifier during the positive half cycle. Okay, so understood the concept, how it is operating for the positive half. Okay, if you understood this, similarly we will analyze the this circuit for the negative half. Okay, so this is the negative half of the AC input signal. So in this condition, negative half, point S2 is positive with respect to point S1. Okay, this is positive with respect to S1. In this condition, this S2 is positive. Go to this point. This positive, if it is it is connected to cathode of the diode D3. So whenever the positive is connected to cathode of the diode, what happens? It comes into the reverse bias condition and it will not operate. It will be in a open. It acts like a open switch. And positive S2 positive, that is connected to the anode of the diode D2. So when the positive is connected to anode of the diode, that will conduct. That comes into forward bias and it conducts. So diode D2 will be in a on position or closed switch position. Similarly, this negative is connected to uh, cathode of the diode D4. Okay, so it comes into forward bias and it conducts, and the same negative is connected to the anode of the diode D1. So since negative is connected to the anode, it become a reverse bias and it will not conduct. So this, during this negative half cycle, which all diodes comes into forward bias? Diode D2 and diode D4. Okay, the diode D2 and D4 are in a forward bias condition, and these are conducts. Okay, and it acts like a closed switch. And diode D1 and D3 are reverse biased, acts like a open switch, and it will not allow any current to flow through it. So now let's see the current flow during the negative half cycle. The S2 is positive, it goes like this. Then D3 is an open switch, so there's no current flow in this direction. It goes to the diode D2. From there, once again, in this diode D1 is reverse bias. There is no any current is allowed to pass through this direction. So current flows from this to load. Okay. Then from the load to the, it goes like this and it reaches to point D. In a point D, we have two paths. One is a D4, one is a D3. We know that D3 is in reverse bias and it is not a closed switch and is not conducting. Current flows to the D4 because D4 is a forward biased. From D to A, then A to point S1. So this is the direction. S2 to C, C to diode, D2 to B, B to the load, load to D, D to A to the switch S1. So this is the flow of current during the negative half cycle. See here, in our both the half cycles, the current is flowing in the same in this direction, and RL is experiencing the same direction of current flow. Hence, even the input negative half is having the negative value, but output will be having experiencing the positive value because RL is getting the same direction current. Okay, during the positive half and negative half. So in this negative half also, it is experiencing the positive half cycle. Okay, so this is the operation of full wave bridge type full wave rectifier. Okay, so go with the circuit diagram and understand how it operates. The only thing you must remember is during the positive half cycle, which all point will be positive and which all diode will conduct and how the current flows. And during the negative half cycle, which point will be positive and which all diodes will come into the forward bias and which all diodes will come in a reverse bias and how the current flows. Okay, that you must remember. Then you will understand what how you will get the output in the bridge type full wave rectifier. Okay, just go with the circuit diagram and try to analyze the function of full wave bridge type rectifier. So I hope you understood the operation of bridge type full wave rectifier. Okay. So what are the advantages of bridge type full wave rectifier compared to your center tap full wave rectifier? So what are the advantages? The main advantage is eliminating the requirement of center tapped transformer. Okay, that is the main advantage of bridge type full wave rectifier. Okay, so I hope this topic is very clear to you. Okay, so if you clearly understood the concept of center tapped full wave rectifier and bridge type full wave rectifier, and then we'll go with the multiple choice questions. Okay, so tell me what is the frequency of output frequency of bridge type full wave rectifier. Okay, just we forgotten that point. Okay, what will be the output frequency? It is also double the input frequency, similar to your center tapped full wave rectifier, because you can see here for one cycle of input we have a two cycles, that is two positive half cycles. Means if it is only one cycle is completing, it is completing the two cycles. So output frequency is double the input frequencies. Okay, it is same in the both the type of full wave rectifier. In half wave it was only one cycle for the one input cycle, so frequency was equal to your input frequency. It is here, it is double. Okay, so having the topics in our mind, by understanding those concepts, we will check our knowledge level by going through the questions. Okay, so first I will read out the question. Okay, and then I will read out the options available. Okay, then I will give some time. So try to answer the questions given here. Okay, then I will answer it. I want you to first get the answer before I explain the answer, so that you can cross check whether you are having the clear idea about these topics or not. Okay, so coming to the first question, question number one, it's a full wave rectifier circuit conducts for dash of AC input. Okay, so it is asking related to the conduction of the full wave rectifier. So when the full wave rectifier conducts, okay, let's go with the options. Option A says one half cycle. Option B, both the half cycles. Option C, quarter cycle. Option D, none of the above. So we have the option, and it is the question is when the full wave rectifier conducts. So can you get the answer? So it's very easy to understand. If you have understood the concept of full wave rectifier, easily you can identify. So is it the first one half? No, the name itself having the full wave, then it will not operate only one half. Okay, so this is not the correct answer. Next one says both the half cycles. Is it correct? Yes, we understood the operation of full wave rectifier. In this, it was operating for the both the half cycle. So this is the correct answer. Then quarter cycle. Is it operating for the quarter cycle? No. So this is also not a correct answer. None of the above is not a correct answer, because we have the correct answer available here. So correct answer for this question is both the half cycles. So question number one, the correct option is option B, both the half cycles. Okay, so let's move to the next question. The center tapped rectifier uses dash. So option is only one diode, two diode, three diodes, and four diodes. So center tapped full wave rectifier, how many diodes it will use? So if you remember the circuit diagram, it's very easy to answer. So how many diodes it will use? So I hope many of you got the correct answer. Okay, let's go with the option only one diode. So just recall the circuit diagram of center tapped full wave rectifier, where it has a center tapped transformer and two diodes are connected, and each diodes are operating for the one half cycle. So D1 and D2 are the two diodes it was using. So only one diode is the wrong answer, two diode is the correct answer. And we were not using any three diodes in any of the rectifiers, so this is also wrong answer. And four diodes. See, the question is not bridge type full wave rectifier. It is a center tapped full wave rectifier. So four diode is also a wrong answer. If the question was like the bridge type full wave rectifier uses number of diodes, then it would be the correct answer. But now the question is related to the center tapped rectifier. So the option B, 2 diodes, is correct. Next question. The efficiency of full wave rectifier circuit is dash. Okay. So it is dealing with the efficiency. Let's see the options. Option A, 40.6. Option B, 50. Option C, 100%. Option D, 80.2%. Okay. So in this session beginning only we discussed about the efficiency of a full wave rectifier. So guess the try to understand or get the output of this question. Okay, let's begin with the option. So here it is dealing with the full wave rectifier efficiency. So first option is 40.6. Is it correct? So don't get confused. The 40.6% is the efficiency of a half wave rectifier, not the full wave. So it is a wrong answer. 50% not a correct answer. 100% is also not a correct answer. 80.2 is a correct answer for this question. So question number 3 answer is option D. Okay. So this is the answer for this question. Let's move on to the next one. So next question is the ripple factor of full wave rectifier is option A 1.21, option B 0.48, option C 48, option D 12.1. So the ripple factor of a full wave rectifier. So in the beginning we discussed that compared to half wave, the full wave is having the lesser amount of ripple. Okay. So guess which one is the correct answer? Okay. Let's begin with the options. So first option says 1.21. So here also there is a chance of getting confused because this 1.21 is the correct answer for the half wave because the ripple factor of half wave rectifier is 1.21, but here the question is regarding the full wave. So this is not the correct answer. Then 0.48, yes, it is the correct answer for this question. 48, wrong, and 12.1 is also a wrong answer. The correct answer for this question is option B, 0.48. So the last question for this session, that is the ripple frequency for full wave rectifier is. Okay. So this is very important question. Even during the session also I stressed it more time, many times. What is the amount frequency in the output of the full wave rectifier? Let's see the options. So option given is 2F0, F0, 3F0, and 4F0. So you already guessed the answer. That is right. That is option A, 2F0, because in a full wave, it is having the double the input frequency. So answer is 2F0. Okay. So this is the session regarding the full wave and full wave rectifier. Okay. So what are the topics we covered in this session? We understood what is the definition of full wave rectifier, what is the efficiency of full wave rectifier, what is the ripple factor, what is the output frequency of a full wave rectifier. Then we understood the types of full wave rectifier, that is center tapped full wave rectifier, and one more is a bridge type full wave rectifier. Then we have gone to some questions related to the topics covered in the today's class. I hope you understood the concept. Okay, thank you.